It has been a unique and challenging past 6 months in the engineering directorate. With many employees still working remotely and dealing with COVID-19 setbacks, EA still managed to accomplish a great amount of work. In this hybrid environment, our team of dedicated engineers have been building the vehicles and tools that will enable future missions to the Moon and Mars while providing real-time support of the missions Crew 3, SpaceX-24, NG-17, Soyuz MS-19, as well as US EVAs 77, 78, 79, and 80. The Volatiles Investigating Polar Exploration rover is progressing and completed its critical design review after several subsystem, element, and instrument-level design assessments, including the mast assembly and motor controllers. The Crew Health and Performance Exploration Analog has also seen big developments in recent months. The crew quarters have been completed, the mechanical, electrical, and plumbing installation has begun, the sandbox is installed, and crew selection has started. Robotic hardware has seen quite a few new developments recently. Hardware that improves comfort of upper limbs during suited operations called Angel was tested in Argos with the Mark III suit with positive results. A new replacement for the Mission Control Big Board display called ND Demos was built, as well as a new lunar rover simulation. A new cryogenic prop supply system, Frostmet, had its test readiness review, which will be key in providing a test stand for sustainable ISRU propellants. And augmented reality is being used for crew training on station with the T2 trainer. Many of the facilities at JSC were improved in order to enhance capabilities and support all of the new projects underway. The first Gateway-ready Avionics Integration Lab capability demonstration was completed. Energy Systems received 2 new battery abuse test bunkers, and installation and test of the generic robot on-orbit trainer by U.S. Space Force trainees. The 6th Degree of Freedom tendon-actuated robot is now operational. STAR is a test bed for precision landing and hazard avoidance technology, and payloads here can be flown with open or closed-loop trajectories with spacecraft simulations. A full-scale dress rehearsal with human subjects was conducted in the 20-foot chamber following the renovations to support advanced exploration missions. Chamber B was successfully tested for cryogenic and vacuum operation evaluation, including exercising an emergency rescue of a test subject. Chamber A had a 3-day warm vacuum functional to verify its system since its last operation in 2017. And Chamber N had projects like the shape memory alloys for regulating thermal control systems. Testing has been ramping up with all of the new systems being built. At ESTA, shock tests for the Artemis II anomaly gas analyzer, thermal runaway tests for the Starliner batteries, compressed gas dust mitigation investigations, power quality testing on the airborne particulate monitor, and acceptance testing for the Orion main engine pneumatic pack purge valve component were all completed successfully. A creep burst test for the Luna Inflatable Habitat test article to validate the fiber optic system and structural health was also successfully carried out. ESTA also conducted the mechanical test phase of the Lunar Auger Dryer ISRU project, which is part of the Lunar Water Processing Plant. And the Light Water Analysis and Volatile Extraction project conducted a boiler heater test. The Supplemental Heat Rejection Evaporative Cooler completed a full-scale heat rejection performance test. The Structures Test Lab performed vibration tests on the T2 treadmill, XCMU visor assembly and environmental protection garment, Orion life raft and medical kit restraint, and the Viper mast. The SpaceX Demo 1 docking system was delivered and accepted at the 6th Degree of Freedom Dynamic Test System facility to certify performance of a new electromechanical motion platform. The Cycle ergometer with vibration isolation stabilization did acoustic testing in the anechoic chamber. Electromagnetic interference testing was conducted on SAFER, Universal Intelligent Glass Optics, AWS Snow Cone, Viper mast gimbal controllers, and Orion flywheel. An end-to-end communications test with all Artemis integrated stack components was successfully tested over a 3-day period to discover and resolve any issues that come up while on the launch pad. The XCMU Portable Life Support System went through its thermal control loop tests as part of the Ambient Lab Environment Acceptance Tests. the spacesuit evaporation rejection flight experiment continued its EVA simulations on orbit to demonstrate its performance. At Argos, the XEMU pressure garment subsystem underwent mobility testing, and an incapacitated crew rescue feasibility study also took place. The Artemis Geology Tools team took part in a desert research and technology study to establish terrestrial field capability and operational recommendations. Also in the desert, the NASA main parachute asymmetry tests were completed at Yuma Proving Ground, where a test vehicle was extracted from a C-130 and 2 mass blocks were released to collect pendulum data. For Artemis II, government certification for parachutes was completed thanks to a big effort by the Capsule Parachute Assembly System team. Guidance, navigation, and control also saw significant progress. There was the 133CA wind tunnel test for the Artemis I CM to investigate the impact of surface roughness on aerodynamics. Multiple builds containing updates to Orion's flight software, LiDAR testing, and full testing for the optical navigation software version were successfully completed, and anomalies were investigated, like the GPS failure during a commercial resupply rendezvous and a space-integrated GPS INS issue during a docking. On station, US EVA 77 saw Aki Hoshide and Thomas Paquette using 2 SEMU for the IROSA Prep 4A. EA supported the installation of MOCHI, a scanning electron microscope with an X-ray spectrometer, and also led the atmospheric leak investigation of the Pearl crack by installing a strain gauge assembly to characterize the dynamic stress. The robotic external leak locator helped to home in on coolant loop decay sources on the ISS, and the first ever 3D printed heat shield re-entered Earth's atmosphere during the Cygnus NG-16 mission. The Copernicus spacecraft trajectory design and optimization system was selected as the winner of the 2021 NASA Software of the Year award. This state-of-the-art tool is used on Orion, Gateway, HLS, and SLS. Our mission trajectory and propulsion system expertise would be put to use through a pilot program where JSC employees were embedded in intuitive machines to collaborate and share knowledge. And Women in Leadership 2.0 completed their program of stretch assignments and service projects centered around increasing diversity in STEM and EA core competencies. While working through unprecedented times can have its hardships, engineers at JSC use this opportunity to show its resilience and deliver results. Our team continues to lead the way for sustained human presence in space, and as we return back to on-site work, we will reunite and work together to continue to build the systems that will push the boundaries of human innovation and imagination.